Hi, Dr. Risk, or whoever's gonna be grading this video. Uh, Heads up, I'm sorry if my voice is kind of raspy. I've been under the weather lately for a few days. So to get started off, my CMAP, it didn't go based off of the guide or the code in the guide provided. I made a I made a my own recursive function. It was actually just about the finding the sum of the terms in the Fibonacci sequence based on the number of terms the user wanted. So just a quick recap of the Fibonacci sequence. It's a mathematical sequence that the next number is the sum of the previous two numbers. So as you can see, when we come here, the first two terms are given since you need two terms to add. So 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 2 plus 1 is equal to 3, and so on and so forth. And I made my program to find the sum of the specific terms, like say that the user wanted the sum of the first 5 numbers or first 10 numbers. You can run it and it will show up the enter number of terms. So like if I say 5, it's going to give 7. And if I want to run it again, and I say 10, it's going to give me 88. So on and so forth. So to start off with the CMAP, I start off with the Fibonacci recursive function as my head, and includes components such as steps of the function, base case, recursive case, and function call. When we go to steps, when we look at the individual steps, step 1 is usually finding the base case so that the recursive function knows when to stop instead of running an infinite number of times. Step 2 is for finding the recursive case, which is practically just calling the function again, where you call a function again in your code, which is made pretty clear by its name. It gives it the ability to be called recursively. And step 3 is carrying out any other operations you need to in the function to get the desired output, or like to carry out the function of the method. And step 4 is calling the function in the main function, because if you don't call the function in the main function, it won't run. And step 5 is just something that I do. It's like I use print statements to ensure that I'm getting the result that I want, and it makes it easier to debug if I have any problem. And it also makes sure that the program terminates when you want it to. So like if I want it to run 5 times and it runs 6 times, I can tell that there's a problem in my code. And then when it comes to a base case, it asks when and how the program would know that it needs to stop running the function recursively. And the result of that is that once the base case is true, then the program knows that it reached the end, and it can return the corresponding value or the desired output, and it will stop running the recursive function. And then the base case in my program, the Fibonacci program, the base case is when the counter exceeds the number of terms that the user wanted. So like if the counter is a parameter, but it's a predefined parameter, so which starts off at 0, and the predefined parameter increments 1 each time the recursive function is called. So the example code is if counter is greater than num of terms, then return 0. That indicates the termination of the recursive function. And when it comes to the recursive case, it asks how and where to call the recursive function again, and what are the new values or parameters that are passed by the function the next time it's run again, resulting that once the recursive case is reached, that is when the function is called once again by itself, and but this time with different parameters. And the recursive case in the Fibonacci program is just calling the function sum of Fibonacci, but this time it passes the same function but with different parameters, like the counter increments by 1, and the second number that is passed originally becomes the first, and the second slot, like as you can see here, the second slot which held the second number is replaced by the sum of the first and second number, and it recalls that function. And here's the example code. Return first, which is the first term, plus sum of Fibonacci number of terms, which indicates how many times we want it to run, counter plus 1, second. As you can see, this slot used to be second, but now second takes this spot, and first plus second. And usually this first, when it's run the first time, it will be 0 because the first term in the Fibonacci sequence is 0. And after that, once we move to the right, we reach the final part, which is just the function call, which is a step in the main function that calls the recursive function, because any function needs to be called in order to be run. And the example code is int main int num of terms. We're initially initiating num of terms as an integer, and then it outputs a message, enter the number of terms, and the user enters 5, 10, 15. And then it takes the user given number as input and assigns it to num of terms. And then to get the result, we just do a simple um, cout to put output on the console, which is sum of first, which space num of terms. So like if they say 5 as an input, sum of first 5 Fibonacci numbers, colon, and then we call the sum of Fibonacci here with the number of terms passed as the parameters. And it ends the line. And overall, that's the CMAP. And if we wanted to look more at the code, as you can see, the return data type of the sum of Fibonacci is an int, and then you get 4 parameters. Int number of terms, int counter, which is originally set to 1, int first equals 0, int second is equal to 1. Actually, you'd want to change this to 0 because you want to start with the 0, like you want to start off by running it 0 times. And then, as you can see, this is my base case. If counter is greater than number of terms, return 0. And this is a recursive case where where the function calls itself. Return first plus sum of Fibonacci plus number with the changed parameters, which is the only parameter that stays the same is num of terms, counter plus 1, and then second takes the place of first, and then the second number slot is replaced by first plus second. And here you can see just a general, nothing too complicated, just the int main, and that's the main function with the integer number of terms, and the user gives input, and then we call the recursive function with the number of terms parameter. And let's just to run it again, say that we want 15, gives us 1596. Say that we run it to 5. We'll get 12 because I changed the counter from 0, so that would change how it runs, because it will run one extra time, instead of um, starting off from 1. So yeah, that's my program, and thank you for watching.